All right. So last time we talked about, well, basically we just finished up the performance section. And so now we're going to kind of touch again on performance, but we're going to talk about more of the weight and balance side of things. And to do that, we're going to first talk about the pilot's operating handbook. And so this is a PDF version of one pilot's operating handbook of some Cessna 172 out there at some flight school. I don't know. They uploaded it. So yeah, this is just one of many different pilot operating handbooks for the Cessna 172. They all look very similar, but each aircraft is given one in particular for that aircraft, and you're required to have that pilot's operating handbook on board whenever you operate it. So we'll be looking through this one. They're pretty much all the same as far as Cessna 172 pilot operating handbooks go, but yeah, I just want to put that out there that they are semi-individualized. Um, so first, I guess I should explain what a pilot's operating handbook is. So the pilot's operating handbook, or from now on, I'm going to call it the POH, is a book that basically has um, components in it that range from your emergency procedures. You'll have your performance charts, so you can calculate takeoff and landing distances. You'll have weight and balance charts, different things that they want you to know about the aircraft. Basically it's the manual for the airplane. And the idea is, if you read it, nobody does that, but if you were to read all of it, that you would basically know everything there is to know about operating that aircraft. And so you don't have to know everything that's in this book, but it's good to know where everything is at. So in the case of an emergency, say, you can pull out the POH, you go to chapter or section 3, and you can find the emergency procedure for whatever is going on. That's the idea. So we're going to kind of talk about the different sections, and then we're going to focus more specifically on the weight and balance section, because that is something we haven't really talked about a whole lot. And then I might, at the end, if we have time, talk a little bit about some of the other documents that are also usually included in this kind of in-flight emergency slash required for operations. So to start, POHs are ordered in this manner. It doesn't really matter what POH you're looking at. They should have these kind of sections and layout, and that's what you should expect to see. So if you got into a Beechcraft or something and you pull out its POH, you should be able to go to section 3 and find the emergency procedures. And this is done just because they want pilots to be familiar with where some of these more necessary sections are at in case of things like emergencies. So the first section is the general section, and this contains your basic information about the aircraft. It contains some helpful abbreviations that are used throughout the POH. It contains, in fact, let's take a look at this. It contains some of your propeller lengths, wing lengths, dimensions of your aircraft kind of stuff. And then, it also has, in this case, a bunch of conversion charts. So you can do fuel conversions, weight conversions, distance conversions, whatever you want. And to kind of give you an idea, so here you can see, you have the plane, and then you have the propeller diameter and the wingspan. And then, further down here, it'll give you your V speeds. So, if you need to remember what VS is, then you can look it up and say, yes, VS is stalling speed, or the minimum steady flight speed. VX, best angle of climb speed, and so on. it doesn't tell you necessarily what those V speeds are for your aircraft. You have to go to another section to look that up, but that's where those the terminology is laid out for you in case you're curious. And then down here, like I was saying, it also gives you all the conversion charts. So, pounds to kilograms, meters to feet, whatever you want, basically. It's all in here. Not that you could do it faster with your phone, but it didn't used to be that way. So section 2 of the book is dedicated to the limitations of the aircraft. And these limitations are usually given in the form of the V speeds. And the V speeds are basically speeds that you should be flying at during a given flight configuration. So for instance, you have VNE, which is the speed at which you're never to exceed. And, you obviously should have, one, a hard time getting to that speed, and two, if you ever get to that speed, you're probably going to be in some serious problems. So, you have that. You'll have your climb speeds, your stall speeds. You'll have your best glide speeds, that kind of stuff. And so we'll take a look at that when we scroll by it, but I won't go there right now since it's quite a ways down. The emergency procedures section obviously has all of your checklists in there for if something goes wrong. So for instance, you have an engine fire. Now it'll give you the checklist in the emergency procedures section. However, there are terms which we call the bold items, or sometimes they're highlighted depending on the POH or your flight school. And these items are what the pilot should memorize. And then everything else that's not bolded is what you can reference after you've done the bolded items from memory. So if you have an engine out, there's a few items that you do from memory, which are the bold items, and then you pull out the POH after you've done those, and you look at what you're supposed to do after that. So those are kind of like the initial action items that will get you in kind of a safe state, so to say. So we'll also take a look at that when we scroll by. Normal procedures. This is your basic checklist. So your pre-flight checklist, your takeoff checklist, landing checklist, cruise checklist, everything that would be done normally during the flight is going to be in there. And these are not necessarily, in fact, I don't know anybody that would necessarily memorize them, but usually you get proficient enough to where you kind of flow through them. And the idea is that you check what you've done. So you do something and you check against the checklist that, yes, this is indeed correct and within the range. The performance section is dedicated to talking about your takeoff and landing distance calculation charts, your crosswind component charts, anything that would have to deal with what speed you're going to be flying at, or a distance to get somewhere, that kind of stuff. And I'll show you an example of that when we go past there. Section 6 is going to talk about your weight and balance. So this is where we're going to find our weight and balance sheets. We're going to see how we can calculate out our CG and our moment, and what the range that we're supposed to be in for safe flight. This section also has an equipment list. So this will tell you what you have to have on board. So, it might include all of your stuff that's required for VFR day flight, obviously. But it also might have some extra stuff that is included in the aircraft, also included in that list. So we'll kind of talk about that a little bit later. Section 7 is going to talk about the airplane, the systems on board. So like we talked about last week, we talked about the oil system and the engine system, electrical system, any of those systems that are, basic to the aircraft operation are going to be in there. And that's going to talk about, how they work, and maybe it'll give you some hints as to if when something goes wrong, what to do, and stuff like that. So just basic descriptions of everything about the airplane. So section 8 is going to talk about, your maintenance items. So if you wanted to change the oil, or if you wanted to maybe change a filter somewhere in the air circulation system or the AC system, or you wanted to change the tire or something like that. This section will help the pilot perform that preventative maintenance, and it'll kind of give you a little bit of guidance as to what to do. So you don't have to go searching the internet for YouTube videos or something. Then section 9 is going to be your supplements section. This can contain a lot of different things. It's kind of a vague term, but oftentimes it will contain information about systems that may not be standard on every single Cessna 172. So for instance, if you had an autopilot, or if you had some sort of special glass cockpit add-in or something like that, then that would appear in this section. It would give you information about that. So that's just kind of a catch-all of anything else. So we talked about the first section, so I'm just going to kind of scroll through this real quick, and we'll jump down to section 2. So section 2 here, you can see we have another table of contents, so we know what's exactly where. So, we have our airspeeds, those are going to be our V speeds, and it'll tell us what the markings are in the aircraft. It'll tell you your weight limits, CG limits, every kind of limit that you want to know. So take a look here. So, here's our basic airspeed limitation. So V and E speed is 163 indicated. So beyond that, we really don't know what'll happen. We're not supposed to exceed it. V and O, which is inside the yellow arc, if you've ever seen that, that is only to be exceeded during operations in smooth air. So, not turbulent, not windy, not anything. So smooth air only, that's 129. And then, you have your maneuvering speeds and your maximum flap extended speeds as well. And after that, we have, the colorings on the airspeed indicator indicating what these V speeds are. So, you have the white arc, which is the flap operating range, the green arc, which is the normal operating range, yellow arc, which is that normal, exceed only in smooth air speed. And then you have obviously the V and E speed, which is the red radial line. So you also get some other information, such as, your max takeoff weight for different categories. So if you're in the normal or utility category, it varies. So obviously the maximum weight here is 2,558 pounds. That's your maximum ramp weight. And then your maximum takeoff weight is 8 pounds less. And you might wonder, well, how can that be 8 pounds less if your ramp weight is more than your takeoff weight? Well, they obviously assume that there's 8 pounds of oil or gas or something to be burnt while you're taxiing to take off. So you can be 8 pounds over, but you have to be 8 pounds lighter in order to take off.
Is that a reasonable amount of gas to be burning in the maybe 10 or 15 minutes you're going to be taxiing even at large airports? That seems like a lot.
Yeah, for a small aircraft, that is a lot. If you do the math, it's probably about a gallon of gas. So, and usually most Cessnas are burning about 10 to 15 gallons per hour. So yeah, it's a lot of gas, but
Not
yeah.
quite as much as you'd think.
Right. Yeah. It's not as much as you'd think, but it's still, yeah, that's quite a bit. So I agree. I don't think you'd be able to burn that just taxiing.
Just sit on the runway hold on, hold up.
Yep. Yeah. And you have no idea. A gallon of gas, that's way too precise to be reading off of an analog gauge. So you really have no idea. But if you were planning that into your calculations and you really needed all the gas you could get, then you would obviously fill up a little bit over, and then you would take off right at 2,550 pounds. But that's in very extreme scenarios. But yeah, it's a little absurd. So yeah, it just gives you all kinds of other limitations. These are good to read through, but I won't spend too much time here. These are very specific to the aircraft, and so whatever you train in, you'll have to know those things. So section 3, this is where we're going to get into the emergency checklists. So let's just take a look at one of these emergency checklists. Let's look at engine failure. Let's look at engine failure during flight. So here we have engine failure during flight. Should have made this bigger earlier. So engine failure during flight, and these are restart procedures. So this is trying to get that engine back working because obviously you need that to fly, or if you don't, then you need to find somewhere to land. So like I was saying earlier, you have these bold items, which are to be memorized. And so you'll memorize these items and you'll perform these in the event of an engine failure. So you're going along and then, for some reason the engine fails. Well, you pitch for 68 knots, which is the best glide speed. You check the fuel shutoff valve, make sure that is on. Check the fuel selector valve, make sure it's on both. Make sure you have your auxiliary fuel pump switch on, just in case the gravity fed one or the main one is not working for some reason. You push the mixture rich, just in case for some reason you left it too lean, or for some reason it came out. And then beyond that point, if nothing happens, then you pull out the POH and you go through the rest of the checklist, which in this case, there's only 2 more items. Check the ignition switch and then check the auxiliary fuel pump switch. Now, at my flight school, we actually had an acronym to remember this, which was, it's basically the alphabet. So you go A, B, C, which it's airspeed, 68, B, which is not on here, but it's a good thing to do, and that's to choose a best landing spot. So whether it's a field or a runway or a road or whatever, you should aim for something to land, preferably, not near wires or houses or something like that. So airspeed 68, best field. C is you go through your checklist. So that's doing all of these items. And then D is declare an emergency. So you set your transponder to the emergency code, which is 7700. And then you would call up the nearest tower, or you would tune into 121.5 and declare an emergency. And then you would do the E, which is prepare to egress. So you would pop the doors out just prior to landing. That way, if for some reason the doors got jammed during a hard landing, you could still get out. And so you go through those, and as part of that C, you would do this checklist, and that was what we would do for our engine failure. So it has all kinds of different ones: cabin fires, wing fires. I mean, you name it, it's in here. I mean, it even tells you how to land with flat tires or whatever. So it's quite exhaustive. And as you can see, also, not everything has bold items. So some things may not be as serious. And in that case, you'll just have to pull up the POH and look it up whenever it happens. And in the back here, it does have a little bit more of a kind of like enumerated, it calls it amplified. Basically, it just gives you more instructions than you get with a checklist about what you're supposed to do in the case of any emergency. So we'll kind of scroll through the rest of this here and move on to section 4. So section 4 is the normal procedures. So we have all of our normal checklists. So pre-flight, your takeoff checklist, landing checklist, cruise checklist, all of those fun things. So this first thing we see here this is actually a diagram of how you should perform your walk around during a pre-flight check. So when you're walking around the aircraft, you should start inside the cabin, and then you should walk around the tail, and then around the right wing, and then around to the other side of the aircraft. Some people do change this up. but as long as you remember what to do and you do it the same every time, then whatever that works. So this is just going to run through in this order. So first, you're going to do everything in the cabin. So you're going to check, all of your parking brake. You're also going to turn your master switch on and check the batteries and check the panels, and you'll also turn your lights on so that when you do the walk around, you can see if your lights are working, that kind of stuff. You'll then move to the outside and you'll check all of your flight control surfaces, make sure all of your control linkages are in place, and that your say your counterweights on your ailerons are in place, and stuff like that. Check your tires, check for leaks, check for inside the engine, check your oil, check belts, that kind of stuff. So you'll go through that, and then you have all your starting checklists. So this is how you start the aircraft. And this is used every time that you start the aircraft, just to make sure that you check everything, because usually there's a reason that something's on here. It doesn't just get on here for no reason. So yeah, you'll use it every time that you go flying. So we'll kind of scroll through here. Actually, I think I saved it. Here we go. So I skipped down to section 5 in a different tab. So here we go, section 5. This is the performance section. And this is where we can find all of our performance charts that will help us calculate takeoff, landing distances, and the such. So if I scroll down here a little ways, let's see, what do I want? I think we'll start with this one. So here we have a crosswind component chart. So this allows us to calculate how much of a crosswind we'll have, depending on what the angle is to our aircraft and how much wind is blowing from that angle. So this is really handy when you want to calculate what your crosswind component will be on a given runway, and if your aircraft can handle it. In the Cessna 172, for instance, it's only rated to fly in crosswind components up to 15 knots. So you cannot take off in more than, well, you could take off in more than that, but this is the maximum demonstrated crosswind. So anything beyond that is something that's not really been tested, and you probably shouldn't do unless it's an extreme scenario or something. But that's beside the point. 15 knots is the maximum demonstrated crosswind, so you should try to adhere to that. So here you can just select an angle and then a wind component and find the intersection, and then you'll just go down to the bottom and see what the crosswind component is. It's a pretty easy chart. But so here's the first example of our takeoff calculation checklist. This tells us our ground roll. Now, there are two different kinds of these charts available. There's one that looks like this, and it is tabular. The other one is a little bit easier to follow and interpolate against, and it's much more graphical. So you basically have lines on a graph, and you can follow the lines up and across the chart. I may have shown you guys this once before, and you can calculate your takeoff and landing distance that way. This type of table, you have to interpolate a little bit and figure out what value is in between these numbers. Alternatively, you could just round up to the next highest level, but that might not always work out in your favor, especially if calculations are tight. So yeah, this is the short field takeoff distance calculation chart, and this is at full weight. So this is full takeoff weight. It also tells you what conditions the test was performed at. So in this case, the flaps were set to 10 degrees. They were full throttle prior to brake release, which is a normal short field takeoff event. So you'll set the brakes, run it up to full power, leave it there for a few seconds, and then once it's spun up, then you release the brakes and go. This was on a paved, dry, level runway. There was no wind, and then they lift off at 51 and they were climbing out at 56 knots. So that's helpful. It helps you give a little bit more context to where this data came from. So to use this chart, you'll first have to calculate whatever your pressure altitude is. So this is pretty easy to do. You just get the pressure outside, and then you get the airport elevation, and you can calculate what your pressure altitude will be. So for the ease of calculations here, we'll just say that it's 2,000 feet. And then you will get your temperature in Celsius. We'll say it's 10 degrees. And then from those two numbers, we can see 2,000, 10 degrees Celsius. We have a takeoff ground roll of 1,110 feet. And then we will clear a 50-foot obstacle, or we'll be at 50 feet by 1,890 feet down the runway. So about 700-ish more than the ground roll. And as you can see, as temperature rises, the distance to take off also rises. And that has to do, again, with the flight performance being much better in cold, dense air than it is in warmer air that is less dense. So yeah. Also, lower pressure also decreases the ground roll. So your sea level pressure at low temperatures is going to be your best performance, and then obviously you have your worst performance out here at high pressure altitude and high temperatures. There's also a little bit more information down here at the bottom, which will help in interpolations for different scenarios. So one, it's telling you this is the short field technique as specified in section 4. So that was one of those previous sections which would tell you how to perform a short field takeoff. You have, it tells you some information about the mixture setting for, fields above 3,000 feet, because you need a little bit extra or a little bit less mixture than you do than when you're lower. So having that little bit less mixture will help give you maximum power and RPM. It also tells us that for every 9 knots of headwind, we'll have to decrease the distance by 10%. And for every 2 knots of headwind, we'll have to increase the distance by 10%. So that's helpful information for, extreme circumstances where you're either taking off into the wind or whatever reason you have that scenario. But most often it'll be this tailwind or this headwind component because you take off into the wind. And so for every 9 knots, you decrease by 10%. And then for grass runways, you'll increase the ground roll figure by 15%. So here we have another one. This is a little bit less poundage. So this is 2,400 pounds. This is 2,200 pounds. Now you notice that they don't give us charts for normal takeoffs. And so the short field takeoff distance, you'll just kind of have to use it for your normal takeoff. There are ways to interpolate to that, but for all intents and purposes, it's not a ton different. The short field takeoff technique, really the only difference is that you hold the brakes and let the RPM spin up. So you might lose up to 50, 100 feet maybe, but it's not too much different. Here we have a max climb rate table. So you again put your pressure altitude in here and your climb speed, and then you can figure out from your temperature what your rate of climb will be in feet per minute. It's helpful if you if you're in the mountains or something, I don't know, and you need to calculate if you can get over the mountains given certain pressure and temperature. That might be helpful. You get your gallons per hour used. You can calculate your cruise performance, so how much fuel you'll burn during cruise at given altitudes, and RPMs. And then you get more altitudes and more RPMs. And then you get this graph, which will help you calculate how much fuel you'll burn given an altitude and a range, given an altitude, and then a power setting, and it'll tell you your range. So you get all kinds of nice charts in here. And then you have your landing charts, which are the same thing as your takeoff charts. So Then finally, we get to section 6, and this is our weight and balance chart, or our weight and balance charts, I should say, plural. So, we get some graphs here telling us where the CG is and what the distance is between each station. So we have the firewall, which is our station 0, and then we have like our pilot seat and our back seats and our rear rear storage compartments and everything else. So that's kind of handy. It gives us some formulas to help us calculate the CG and some other stuff. Gives us some basic empty weight calculations, so we can calculate, what is our empty on the ramp weight of the aircraft, and that's what we'll use for all the rest of our calculations for weight and balance. So this basic empty weight is our base number. So everything else adds to that. Keep going here. Again, we have this another diagram of where our stations are. So 0 is our firewall, and then going back towards the rear of the aircraft, our stations will increase, and this number will help us determine how much weight is given to the weight at that station. So this is 37, and this is measured in inches, I believe, and so this is 37 inches back from the firewall. 73, such and such. So, so that's used to calculate your moment and your CG. More charts and more stations. And finally, we get to our weight and balance chart. So this is what you'll fill out, and it's required prior to every flight that you do weight and balance. You don't have to do this paper one, but if you have FlightAware or not FlightAware, you have an e-flight bag that does this for you, or you have an online tool that you use prior to going out and flying. That works as well, but this is the paper variant, the old school variant. So how you use this is, first you have your basic empty weight, and this is a fixed number. It doesn't really change unless for some reason you get a fuel upgrade or an oil upgrade, or you repaint your airplane or something like that, or you put in new electronics. Then this weight will change, but other than that, this remains constant. So in this case, this aircraft, and this is part of the personalization for your aircraft, is that you'll have this number in here. So that's part of the reason why this is important to be individualized per aircraft. So in this case, we'll have an empty weight of 642, which is the sample data. So 1642 pounds. And it tells us that the moment of that is 62.6. And that moment is the pounds per inch. So that's that distance from the 0 point against the pounds. And then this is divided by 1,000 just to keep these numbers small. Then we'll put in whatever our usable fuel is at 6 pounds a gallon. So if we're carrying the maximum fuel, in this case, it's 53 gallons. However, it usually is not max fuel, because then you can fit less stuff in there. So usually you only fill it up, a half or a quarter, or not a quarter, 3/4 of the way full, and then the rest you'll fill up with people and bags and stuff. So usable fuel, you just multiply the fuel by 6, and then you'll figure out the moment at that station, which they have a chart down here, which is used to calculate that that moment number. So if you were at full fuel, you'd be all the way up here at the top, which would give you a moment of like 15-ish. So you go over here, and then you'd put your poundage and then your moment. This is a sample, so poundage and moment. You have your pilots and front passengers. So these are added together. So 340 divided by 2, like 170 per pilot in the front. So 340 all together. And then once again, you'll come down here to this chart, and then you'll find the pilot and front passengers line, and you go up here to 340 right in here, and you'll follow the line down. It's like what they say, 12.6. So, and you do the same with the rear passengers. You find their weight. You go down to the chart, and you go to the rear passengers, and you find their weight. And you go down to the moment, and then you'll get the moment of those passengers. So 24.8. And then you have some extra bags, which in these rear baggage compartments, you can only carry a certain amount of weight. So the first baggage compartment is only 120 pounds, and the second one is only 50 pounds. So not a ton of weight back there, but it's enough to get you where you're going. So, and then you'll have your ramp weight and moment. So this is the total of all the columns above it. So add your basic empty weight, all your passengers, all of your fuel, all your baggage, and you'll get your moment by adding all the moment columns. And this is where you'll take off your fuel for, run up your taxi, that kind of stuff. So in this case, they're subtracting 8 pounds, which that again is a lot of fuel to be subtracting, but we'll give them the benefit of the doubt. And as you can see here, they ended up right at 2,550. So they will be safe for takeoff. And then we have a moment total of 112.8. So now what we can do is we can take those numbers, we can come down to this graph. And this is our center of gravity envelope graph. And this is how we'll determine if our CG is safe for flight. Because if it's too far forward, that's not good. We might never get the nose off the ground, or if we do get it off the ground, it'll be highly unstable, or it might be too far back and we might never be able to get the nose down once we take off. So those are kind of the two extremes. And so that's why we want it inside of these envelopes, especially if we're inside the utility category, which basically means that we're going to be doing like say spins or special maneuvers that would stress the aircraft beyond what you do in the normal category. And so in order to determine if you're inside that CG, you'll take the moment of the airplane, which we calculated it was 112.8. You'll come down here and you'll find 112 just somewhere in here. You'll go up and you'll find the maximum weight, which is 2,550. And as you can see, we are just in the upper right of this CG envelope. So we're good to go. And we can go fly. Now, if you were a little bit over to the right, means that you need to probably take off some weight or some fuel or something. And if you're outside the envelope down here, probably means that your CG is off and you probably need to shift some weight around the airplane to get up into that normal category. So yeah, you also got this extra chart here, which helps locate the CG, or helps determine what category you're in based on the CG location in inches after the datum. But normally we use this chart, so I wouldn't really worry about that or anything else here. So yeah, that's weight and balance. It's pretty simple. You just follow, you're basically just adding up a bunch of numbers, and then you're following lines to figure out if you're in CG. So obviously there's a lot of time and data that went into creating these graphs, but using them is pretty simple. So any questions on using any of these charts or graphs or anything?
So they've calculated the basic empty weight there, but you said that has to be done for your plane.
Yes.
Obviously that'll be taken care of if you're at a flight school, but like, how would you go about calculating that? Because you can't just sum every part of the plane and figure out where the center of gravity is by adding it up because you don't know how much every part of the plane weighs.
Correct. So the basic empty weight, if you're buying an airplane new, is going to be done at the factory. So inside the factory, they have a special scale, and they'll put the airplane on that scale, and they can figure out this data. If you buy the aircraft from someone else, and let's say you get it repainted, then what you'll do is you'll take it down to a special, usually maybe the mechanic will do this, but they'll have special stations you can go and you can run your airplane up onto these scales and you can weigh them. So no, it's hard to determine, where exactly the CG is, but I'm not exactly sure how they do it, but somehow these scales are able to determine this number. So
Give it
yeah.
to some maintenance person and they do some magic. Works for
Yeah,
me.
yeah, exactly. Just some maintenance magic. So, yep. So yeah, that's weight and balance. Not too tricky, I don't think. And then the other thing you have in this section, you also have your equipment list. So this is going to be everything in the aircraft that you have available to you, and it'll give you your weight, your arm. So they have that available to them as well. And it's quite exhaustive. So section 7, your airplane system descriptions. This is basically talking about everything that makes your airplane run. So everything from your airframe to your lights to your electrical system. It shows you your control linkages back to your control surfaces. It gives you your control panel, all of your dials and switches and gauges. Basically anything you want to know about your aircraft that's not in any of the other sections is here. So how to use the seats, how to use the seat belts, how to, everything. So it's quite exhaustive, and it's quite good, but it's a long read, so wouldn't recommend it necessarily. But some of the big stuff is good to know, like your electrical system and your oil system and that kind of stuff. I think I skipped over. Yeah, I missed section 8 here. Let's go back up. All right, so section 8, this is how you should perform maintenance. It also tells you, what to do to tie down or to store it away in a hangar, and some just basic care items. So, for instance, let's go down here. If you need to know how to tie down your aircraft, you look here and it tells you what to do. So you set your parking brake, install the control wheel lock, which prevents the yoke from moving. And then you install a lock on the rudder so that it cannot move back and forth. That's usually done on the outside of the aircraft. You'll put ropes or chains onto your wing. You'll have little eye hooks on your wing, and you'll run the ropes through there. And then there's also little eye hooks on your tail section and the nose section sometimes. And you just run ropes through there, and then you'll either, if you're on pavement, you'll tie it down to the spots on the pavement where they have tie down spots, or if you're on grass, then they make special stakes you can put in the ground to tie down to those. And then obviously you'll install your pitot tube cover or any other outside covers that will prevent things from getting inside your aircraft, or special ports inside your aircraft. So this also includes your cowl coverings to prevent birds from building nests inside your engine. It also gives you information on, oil. So we have what grade of oil to use for certain temperature ranges. And so if you, for instance, were flying, I don't know, in really cold weather, then you might want to put a 20 or a 30 or 20 W30 in your aircraft to help with that colder temperatures. Also gives you information about how much fuel, what type of fuel the engine can burn. So in this case, a Cessna can burn both 100 low lead, which is blue, and it can also burn a little bit rare. In fact, I don't know, I've never seen this or seen it available, but it's 100. So it's not the low lead variant, but that's green. So it can burn either one of those. Tells you your fuel, your max fuel capacity, and how much per tank. Yeah, just basically a bunch of cool information about how to keep your aircraft nice and keep it from getting damaged. And finally, we get into the last section, which is the supplements section. And this section is just a bunch of random stuff that doesn't fit anywhere else really. And so in this case, we have some of the navigational systems, and we also have some GPS systems inside this aircraft. And so these obviously aren't always included in the base model, and so these are included here to look at. So we have all of these, and so we have the supplements for all these different systems, which are usually supplied by the manufacturer of those systems. So here we have our instrument navigation and radio navigation systems. We have down here a little ways, maybe, I thought there was a GPS system somewhere down here. This is the transponder. You get more panels. Your ELT. So making sure that's up to date. Your ELT again needs to be checked to make sure that it's and have the batteries replaced or have them recharged per the FARs. So it tells you all that information. And yeah, this is kind of a long part of the POH, but I think you get the point. So yeah, that is in very brief synopsis, but going into slight detail, the pilot's operating handbook. So overall, are there any questions about that in general or any specific part?
Well, don't think so.
Cool. Well, glad that makes sense. I guess since I have a little bit of time left, I can talk about some of the other stuff you can use. Or other documents that are sometimes included. So you'll have the POH in your aircraft, which obviously you're required to have, and that's your go-to for where to look in case of an emergency or in case of checklists and that kind of stuff. Inside your aircraft, you'll also usually have some other documents which include, and I think I talked about this in the FARs, but you'll have your aircraft registration, which will sit in some inconspicuous spot so that everybody knows where it's at. And you'll also have your charts and your documents. So these are for wherever you're flying. So if you're flying in like Grand Rapids, You'll have to have your Chicago sectional chart, which doesn't have to be paper. It can be electronic as well. But you'll have your charts, and then you'll have your chart supplements, um, and then which we talked about a few weeks ago. And you'll also have sometimes, not always, but sometimes you'll have some extra manuals for some of the other things that might not come standard in your POH. So if you installed something aftermarket, like a GPS or something, you might have those as well. And then beyond that, there's not going to be a ton of other manuals inside your aircraft. Usually the POH is the kind of the end all and be all. And so it has everything you need. Some aircraft also have a minimum equipment list that they're required to carry based on the FARs and based on their whoever's operating that aircraft. They're required to have a minimum equipment list, which is different than what's in their POH. So they'll carry that on board as well. So yeah. So these are kind of the required documents that you're required to have on board during a flight. And beyond that, obviously the pilot has to have their pilot's license and a driver's license and medical. And yeah, that's pretty much all you need to go flying. So next week we will, I think, talk about physiology. So we'll talk a little bit about the night type illusions, and we'll talk about like hypoxia and just some basic human physiology and human factors. So I think beyond that, we don't have too much else to cover. I think human factors is kind of the last big section. So after that, we'll probably just go through some FAA test prep stuff, and that'll kind of be it. So
Aiming to get this whole thing done on time, I see.
I hope so. I hope so. Yeah, it's been interesting only doing it once a week and getting it done in 2 semesters. So we'll see if we're able to make it or not. But